So here's number 32 from this week's assignment or practice, just dealing with the photoelectric effect. So remember, in the photoelectric effect, we have this photon coming in. So there's this photon with the specific wavelength and frequency, and then we have this metal, and there's an electron there. So there's this work function, which is needed to knock the electron off. And then if there's extra energy, that goes towards the kinetic energy of the electron. Now the first one asks for photocurrent as a function of frequency. Now current is the amount of electrons. If we were to increase the frequency of this incoming photon, so this is the photon that's coming in, if we were to increase the frequency of it, it would have more energy. So this electron would get knocked off with more kinetic energy, but there's still only one photon. So if we only increase the frequency, we're increasing the energy of those photons, but not the amount. So the photocurrent should not change as I increase the frequency. If I increase the intensity, however, so now intensity is the amount. So now actually I have more photons. So if I increase the intensity, I have more photons, which means I'm going to knock off more electrons. So there will be more photocurrent. So photocurrent will increase as the intensity increases. And then the last question is photocurrent as a function of stopping voltage. This, I think, kind of gets back to that first question, where the stopping voltage is really the measure of the kinetic energy. Because we use these parallel plates, these electrons are knocked off, and then we try to stop them right there so we know their change in energy, and so we know their kinetic energy by knowing the voltage between those plates. So that's what we mean by stopping voltage. Now, as the photocurrent goes up, the stopping voltage isn't going to change because those electrons would still have that same amount of kinetic energy. What would change the stopping voltage is if the frequency went up. So if there's more and more energetic photons coming in, then that electron would come off with more energy and there would be a higher stopping voltage. So photocurrent as a function of stopping voltage would not change. And that's why those graphs look the way that they do.